Hi, welcome to Chapter 12, Section 4. Today, there's other vocabulary in this section, but I think you can get that from the PowerPoint. I just want to make sure you're able to interpret the graphs from this section. So there are two kinds. There's a heating curve and there's a phase diagram. The heating curve always they both actually look the same way every time. You just have to interpret the different parts. So on a heating curve, you're going to have a certain amount of heat added to a substance. And what you should have learned by now is as heat is added to a substance, it can do one of two things at a time. So it can either change temperature, and you know that. If you add heat, the temperature goes up. If you remove heat, the temperature goes down. Or you can change phase. So you can go from a solid to a liquid to a gas. Heat can't do both at the same time. So when you're making pasta at home and you put the water on to boil, and it comes to a boil, it boils at 212 degrees Fahrenheit. And no matter how high you put the gas up or how you crank up the electricity, it's gonna stay at that temperature until all the water is gone and turned into steam. So once you get the pasta in there, there's no need to keep the heat up. You just need to keep it boiling because it's going to stay at that temperature. It's not going to be able to boil any faster. It'll boil faster, but the pasta isn't going to cook anymore because you're keeping the temperature the same. So that's what you need to keep in mind. Heat can change temperature or change phase, but not both at the same time. So on a heat curve, on the x-axis, and we're only using the first quadrant, all the positive stuff. So the heat is what's going to be on the x-axis, and we're just going to add more and more and more heat. And then on the y-axis, on the positive y-axis, these are the temperatures. And they're usually in Celsius, sometimes in Kelvin, but that's not really even the important part. The important part is to knowing what the graph is telling you. So there's different sections. Every graph, though, pretty much looks the same. You start out with a part that's sloped, and then a horizontal line, and then a part that's sloped, and a horizontal line, and then a part that's sloped. And if you want to think of these as letters, this will be section A, and this is B, and this is C, and this is D, and this is E. So over here at A, heat's being added, and the temperature is going up. I mean, you know that. It's going from whatever. You don't even need numbers. You can tell it's happening. So at part A, this is where the substance is just a solid. It's just a solid. So if this were water, this would be everything below 0 degrees Celsius because water freezes at 0 degrees Celsius. And we continue to add heat. And if you notice, at part B, the temperature stays the same. And the temperature is staying the same because this is where it's changing phase. It's melting. It's going from a solid to a liquid. And this is where melting is happening. And it'll stay, if we had a thermometer in this, it would stay stuck at 0 degrees and it wouldn't go up until all of the solid, all the ice had melted into a liquid. So then at this point here, up to here, it's changing temperature again. When it's changing temperature, it's just a liquid. So once again, if this were water, it would be going from 0 up until this point. And this point here, that's the boiling point. The boiling point of water is always 100 degrees Celsius. So at part D, this is where it's going from a liquid to a gas. So both of those phases are going to be there. And just like melting, the opposite of melting is freezing. If we were to remove the heat, we call it boiling. It can be also called vaporization because sometimes things will turn into a gas and you don't think of it as being hot. Like dry ice is really carbon dioxide, and when it turns into a gas, it's not hot, it's usually room temperature. So it's boiling or vaporization, and if you go in the opposite direction and remove the heat, this is where we have condensation. And then at this point right here, all of the liquid has turned into a gas, and then the gas is just getting super heated, I guess, and that's it. So that's how a heating curve works. The other graph that we're going to use is a phase diagram. Phase diagrams are also almost always the same. On a phase diagram, you have temperatures, sometimes in Kelvin, but usually in Celsius. And then you have pressures, usually in kilopascals or something like that. Because if you think about it, if you can push the particles together, you can make them into a different phase because you're pushing the particles together, you're overcoming those intermolecular forces. So on a phase diagram, the other one was a heating curve, this is a phase diagram. It usually looks something like that, like a Y. And then this is always where there's a solid, this is where there's a liquid, and this is where there's a gas. Every single time, solid, liquid, gas. And at this temperature and that pressure, that's when this substance is going to be a solid. So there would be a list of temperatures and a list of pressures, and where they intersect, then you can tell what phase there's going to be. The lines represent the phase changes. So as you go from a solid to a liquid, this is where the melting happens, across this line. And then from a liquid to a gas, this is where boiling would happen. Like at this particular temperature and pressure, actually on the line. Now down here, this is a little bit trickier, but it's still a phase change. When you go directly from a solid to a gas without ever being a liquid, this is where sublimation happens. Okay. And then there's 2 points that are important. This one right here, where all 3 of those lines come together, that's called the triple point. Because it's, you know, triple means 3. And this is the pressure and temperature where all 3 phases can be present. It's really weird. You can actually Google it and find YouTube videos where people can do it. I can't do it here. I don't have the ability. But at that point right there, that's a particular temperature and pressure. And at that point, all 3 of the phases of this substance can be present. The other point is up here at the end of this line. This is called the critical point. And the critical point, what happens on this line, it's in between the liquid and the gas. Anything beyond this, any temperature beyond this, any pressure beyond this, it doesn't matter. Beyond this critical point, the substance can only be a gas. It can't be anything else. So they'll ask you questions about, like, they'll give you a particular temperature and pressure and say what phase is present, or what happens when you go across this line, or what happens when you go across that line, or if you raise the temperature at this pressure, what will happen. It'll just go from a solid to a liquid to a gas. It's just another way of representing one particular substance, what can happen to it if you change the pressure and the temperature. And it has to do with those intermolecular forces and the way that the particles are arranged. More pressure, you can push them closer together, and they can go from being a gas to being a liquid to a solid. It's not just about adding heat. You can also change the pressure. So the temperature is a change in heat, but the pressure is going to be just pushing the things closer together or allowing them to expand. So that's the difference between a heating curve and a phase diagram.